Okay, so we're going to be working on a new topic here, something that we haven't really talked about before. And what we're going to be talking about is something called a radian. And the term itself is going to be something that's going to be new to you. It's sort of a different way to discuss angles and lengths and those types of things when we're talking about circles. Now let's assume that the circle that you see here on this little XY grid has points at 1, 0. This point up here is at 0, 1, and so on around the circle. So that we know that the radius of this circle from the center to one of those points, the radius of this circle is going to be 1. Okay? Now, let me make this 0 a little bit clearer there. Now, we all know that there are 360 total degrees in a circle. So if you think about me starting here and going all the way around this circle right back to where I started, that's a total of 360 degrees. Now I'm going to go ahead and kind of delete that off of here for a second. So if you kind of think about the portions of this circle, up here where this point is, that would be 90 degrees. Okay, over here, this would be 180 degrees, or half of a circle. This down here would be 270 degrees. I'll go ahead and write my 90 degrees up here. And then when I get all the way back here to where I started, you could either look at that as 0 degrees or 360 degrees, whichever you want to look at it as. Now if you think back to geometry, we know that the circumference of a circle is 2 times pi times radius. In this particular case, we just got done discussing how my radius is 1, okay, because this distance from the center of the circle to the edge here is equal to 1. That's a radius of 1. So in this case, my circumference is just equal to 2 pi. Alright, so if I want to look at this circle not as a matter of degrees, but as a matter of length, the length of the circle, starting at this point, and once again going all the way around, is a circumference of 2 pi. That being the case, that means that if I just start and go halfway around over here to where the 180 is, that would be the length of pi. If I just went up here to where the 90 degree is, that would be a length of pi divided by 2, or 1/2 of pi. And if I went down here to where the 270 is, that would be a length of 1/2 pi. Or instead of writing it as 1/2, I'm going to write it as 3/2 pi. Same thing as 1/2. Okay, so I almost start at like 0. When I get a quarter of the way, that's half of pi. When I get half of the way, that's pi. When I get a little bit further there, that's 3/4 of a pi. And then the entire circle has a circumference of 2 pi. This is the beginning of what we're going to call the unit circle. Okay? Now, what you can see here is that we have these pairs. Okay? When there is an arc length of pi over 2, it's also a degree measure of 90 degrees. Okay? We're going to be able to start converting back and forth between radians and degrees. I want to be able to do that conversion without having to write all of this on the unit circle, because there's going to be other angles. Okay? If I just threw in here like an angle like this, let's say it was a 40-degree angle. Well, I want to know what is a 40-degree angle in radians. And that's what we need to be able to do. I want to be able to convert those without necessarily needing to use the unit circle. So how are we going to do that? Well, a couple different ways. When I want to convert from radians to degrees, I'm essentially just going to multiply, whoops, let me undo that. Let me choose the correct pen here. I'm going to multiply by 180 degrees over pi. Okay, and when I do that, it will enable me the opportunity to essentially kind of cross out the radians and be left with degrees. I'll be left with degrees. Now when I want to convert from degrees to radians, basically getting rid of the degrees, in that case I'm going to, and you may be able to kind of guess this, I'm going to multiply by pi over 180 degrees. Because in this case then, I'm going to be able to cancel out the degrees and I'll be left with radians. So, let's convert 50 degrees to radians. Okay, I'm going from degrees to radians. So in that case, I'm going to use this over here. Okay, if I'm going from degrees to radians, I'm going to multiply by pi over 180. So I'm going to have 50 degrees times pi over 180 degrees. Now, if you're saying to yourself, I'm never going to be able to remember which one I use, whether it's 180 degrees over pi or pi over 180 degrees, here's kind of the thing. Remember that when you multiply, you can cancel anything from the numerator with anything from the denominator. In this case, one of the things we are canceling is this degree. And if the degrees are both in the numerator, then I can't cancel degrees. So for that reason, I want to have degrees in the denominator so that I can cancel the degrees in the denominator. Alright, now you can cancel before and then multiply across, or you can multiply across and then reduce. I would recommend reducing first. I see I have a 50 and 180. Well, each of those can be divided by 10. 50 can be divided by 10 and you'd be left with 5. 180 can be divided by 10 and you're left with 18. So now when I multiply straight across, I'm left with 5 pi over 18. And that's 50 degrees in radians. Okay? See, you know, if I go back to this previous slide and you kind of think about, okay, whereabouts would 50 degrees be? Well, it'd be right about there, somewhere in there. Okay? So if you think about what 5 over 18 is, 5/18, okay? 5/18 is a portion. It's smaller than 1. It's actually smaller than a half because 9 over 18 is a half. Okay? So, and since we know half is right here, and this angle is over here to the right, I know it has to be less than a half, and it turns out to be 5/18. Undo those couple things just so to not clutter that up. Okay, now I have a second one here where I'm going to convert from, this time, radians to degrees. So I have pi over 6. If you can't remember which to use when, well, I want to cancel out pi, and I want to be left with degrees. So I want degrees in the top, pi on the bottom. Pi cancels with pi. That's just like, you know, 3.14 and 3.14 canceling out. If I look at 6 and 180, well, 6 goes into each of those. 6 goes into 6 once. 6 goes into 180 30 times. In the numerator, I just have 30. In the denominator, I just have 1. So pi over 6 is the same thing as 30 degrees. So if you go back here once again, 30 degrees is right about here. Pi over 6, 1/6 of pi. There you go. And that is how to convert from degrees to radians and radians to degrees.